All right, good morning, guys. Welcome to the notes for 3.1 Extrema on an Interval. In this section, we'll be introducing the ideas of absolute, maximum, and minimum values, as well as relative maximum and minimum values. Our first step is just to define what is meant by an extrema. Extrema is just the plural of extreme. You can have extreme values that are either minimums or maximums. So here's our definition. You might want to pause and take a second to write them down. F of c is a minimum value of your function f if it is the lowest value. If f of c is less than or equal to all other values of the function, and this notation here is just saying for every single x contained in the interval. That fancy symbol just means it's contained in the interval. Likewise, f of c is a maximum value of a function f if f of c is greater than or equal to f of x, meaning it is the largest value for all the values in the interval. It's exactly what you think of it as a maximum or minimum value in regular everyday language. There's really nothing different. The minimum and maximum of a function on an interval are the extreme values, or we call them extrema. The plural is extrema. Absolute maximum and minimum values are the highest or lowest values of the function over any closed interval. And I drew you some pictures here. Okay, it might look kind of like you're maybe used to. Think about something simple like a parabola. The vertex plays the role of the absolute minimum in this drawing, or if it was upside down, the absolute maximum in another drawing. It's the highest or lowest value of the function. On the right of that picture, though, is a second picture. It could be that you don't have what you might think of as a highest or lowest value. It could be that your function is strictly the lowest value is the one you start with, and because it's growing, the highest value is the one you end with. That's why they include the word closed in the definition, because you want to be able to include those endpoints as possibilities. It could be that the highest or lowest value just happens to be the first or the last value on the interval. We're going to contrast that, and this will be the highlight of 3.3 section notes, would be a relative maximum or a relative minimum value. These are high or low values in a certain open interval. We talk in calculus sometimes about looking at a window around a certain portion of a graph. So in this sketch here of a cubic function, I have what we would refer to as a relative maximum. There is no absolute minimum or absolute maximum for this function because the arrowheads are pointing up and down, right? I will always continue to grow on the right or drop on the left, so there is no absolutely highest or absolutely lowest. But it's interesting that there's a high point, right, where I've labeled the relative max. For that little zone, right, between my little markings here, it is the highest point in that area, or it is the lowest point in that area. So those would be referred to as relative maximums or relative minimum values. The first group of problems in your homework is going to look like example 1. If you were in class today, I would ask you to take a break here and try to just guess what the values are. They've given you some choices. You're going to label A through G either as an absolute maximum or absolute minimum, a relative maximum or a relative minimum, or maybe it's just none of the above. Plenty of points on that graph are going to just be neither. So take a second, stop, make a list for yourself. I'll show you mine here, right? And see if you can just identify what each of those points should be. Okay, so after you've taken a moment to work through those, we'll go through the answers. A would be considered an absolute minimum value. If you look at that graph, it is the absolute lowest. It is the lowest value that function takes on all of the y values that are shown. Notice there's no arrowheads on this graph, so it's not just dropping, it stops at A. Right? At B, I've already done the little window around it there. It is a high point. You have to look a little closely to notice that B is a little bit lower than G is. So B would be called a relative maximum. Right? It's the highest point in its little area. It's a turning point from where the function increased, and now it starts to decrease again. C is tricky because you want to use these new labels, but C being sort of in the middle of my function is just neither. D, kind of like B, right? It's a low point for the points in its little area, so it would be a relative minimum. And abbreviations are fine. I'll just quickly go through E and F. Both of them are relative, max and min, relatively speaking. And then G is a little bit tricky. It gets people every year. The key to g is that it has that open circle on the end. So while you want to maybe say that g is an absolute maximum value, because it looks like it's pointing at the highest value of the function, because I can never actually get to that point, it would just